Hi everyone, so in this lesson I'm going to go over lesson 2, which is graphing with transformations of functions. So the first lesson talked about parent functions, which is the original function, and now we're going to talk about moving these functions by translating them. You should remember from geometry terms such as dilations, contractions, reflections. You should remember dilating them, reflecting them, shifting them in some way. These are all things that you should remember. So when you translate something vertically, it's called a vertical shift, and the graph would be moved up or down. When you move something horizontally, that's left and right. It's going on the x-axis. This is left and right. Vertical dilations and reflections. We call this in a vertical direction a stretch or a shrink. For example, that would be like taking a circle and stretching it vertically, sort of making like an ellipse. If you guys know what an ellipse looks like, it's like an orbit. So here's your circle. If you stretch it vertically, it would stretch more of like a rubber band kind of deal. The horizontal dilation is the same idea. It would be a stretch or a shrink. And you would just be stretching that circle left and right. So that would also create a sideways ellipse. Okay, so now what we're going to do is we're going to manipulate a parent function that you guys will not be familiar with. It's just mostly like a jaggedy shape here. But the first thing before we even start that, we have to remember that f of x really means y. Okay, so these are all talking about the y values. F of x name is the function's name. This is the function of x. So what I'm going to do is I'm going to fill in my table, and I'm going to manipulate f of x, the function of x. So the first value is going to be on my table this point here, and then the second one will be this point, the third one will be that point, fourth one will be this point, and the fifth one will be that point. So the first point is negative 1, 2, 3, 4, 1. The second point is negative 1, 1. The third point is 1, 3. The fourth point is 1, negative 2, 1, 2, negative 3. And the last point is 1, 2, 3, 4, so 4, 0. Okay, so what we're going to do is we're going to change these values of the function. So there's going to be a left and right shift, an up and down shift, and some dilations and reflections. When you move of something up and down, you're moving it along the y-axis. So the examples that will be moving it along the y are these two guys, because if you notice, we're just adding y plus 3. We're adding y minus 2. So I'm basically bringing every point and moving it up 3 for this one, and this point would be down 2. So this whole figure basically is going to move either up 3 or down 2 for this graph right here. Okay, so I'm going to take each point here and I'm going to shift this up 3 units. So I'm going to take each point and translate it up. So this is going to go up 3 for the first one, 1, 2, 3. So 1, 2, 3, 4, 1, 2, 3. And this makes sense because if you notice here, negative 4, 1. If you add 3 to this, it should become 4. So I think I made a slight mistake here. 1, this is my original right here. So 1, 2, 3. Yeah, so that should be at 4. So let me fix that. Okay, so it'll be 1, 1, 2, 3. So 1, 2, 3, 4, 1, 2, 3, 4. Okay, and the next one I'll move this original point right here up 1, 2, 3. So I would make a point right there. Oh. Okay, and then I would follow suit with the others. So I would move this point up 3, 1, 2, 3. So that's going to go right here. And then the next point up 3, 1, 2, 3. So I'll go about here. And then the next point, 1, 2, 3, 4, 1, 2, 3. This is my translated function, up 3 units. This one is the same thing as this guy, except you'd be moving every point down 2 units. So you would count down 2, down 2, down 2, down 2, down 2. If you want to see what that one looks like, you can look at my key. But the next one is we are going to go ahead and talk about left or right. I don't want to make this video too long, so that's why I'm not going to go over the next one, because all you would be doing is moving the points up, down 2 for this guy right here. Okay, but for this one, this is a little bit different. If you notice, there's an x plus 1 inside the parentheses. Whenever you're inside the parentheses, you're changing it from left to right. When you're outside the parentheses, you're changing it from up or down. In this case, when it's a plus 1, I know it seems correct to be going right, but actually what's happening is we're moving it left 1 unit. Okay, and that's because every x value is being added 1 in a way. But it's opposite of what you think, because if you remember, if you set this equal to 0, it actually ends up creating a -1 shift. So that's why it's moving to the left 1 unit. So every single point on this graph is going to be moving left 1. So that means that this point here is going to move left 1, this is going to move left 1, left 1, left 1, and left 1. So I'm going to move every single point. So -4 is going to become -5, 1. -1 is going to become -2, 1. 1, 3 is going to become 0, 3. -2, -3 is going to become -1, -3. And then 4, 0 is going to become 3, 0. Okay. Boom. All right. This one here is very similar to this guy here. He will be moving right 2, I'm sorry, because it's a minus. When you're subtracting on the inside 2, you're moving it right 2 units. Now these last 3 here, and by the way, you might not see these because it printed incorrectly. If it did print correctly for you, good. But if not, you can just make little sketches of it. But these guys here are affecting the y value in a different way. This affected the y value by adding 3 and subtracting 2. This is how you shift it up and down. But these guys are affecting the y value by multiplying it. And when you multiply something by 2 or 1/2, you're doing something to that value. In this case, you would be doubling it. In this case, you'd be halving it. This is going to do something different to it. It's a negative, so it's going to change the y value's charge completely. So like all these will become negative, and we'll see what will happen there in a second. So remember, f of x means y, so really this is 2 times y. So what I'm going to do is I'm going to take all these y values here and times them by 2. Okay, so my first value would be -4, 1. If I times the y value by 2, I get -4, 2. So -4, 2 is the first thing I'm going to plot. -4, 1, 2, 3, 4, 1, 2. -1, the y value originally is 1, times 2 gets you 2. So I'm multiplying all these guys by 2 right now. Okay, 1, 3 times 2 is 6. -3 times 2 is -6, and then 0 times 2 is 0. Okay, so I'm going to plot these points. -1, 2, 1, 6 is up here, -2, -6 is down here, and then 4, 0 is going to stay. 1, 2, 3, 4. Now, if you can see it, it kind of stretched the whole thing vertically. It stretched the whole thing up and down vertically. Complete stretch. It stretched the whole original parent function. I'm going to save this one for last. We're going to shrink this guy. But just so we can label what's happening here, and the one we just did, is going to be titled a vertical stretch. And in math, we sometimes say by a factor of 2. That's what you're multiplying by. And what I'm going to do in the next one is I'm going to multiply everything by 1/2 of the original. So all these values here will be multiplied by 1/2. Okay, so -4 become -4, 1/2, because 1 times 1/2 is 1/2. -1, the 1 will become another 1/2. 3 times 1/2 is 1.5. -2 negative 3 times a half is negative 1.5, and that's still going to stay 4, 0, because anything times 0 is 0. Okay, so I'm going to plot these points. Negative 4 half is about here. Negative 1 half is about here. Nothing completely accurate, just trying my best. 1 1/2, so 1, 1 1/2. Negative 2 and 1 1/2. That's going to be a full box and a half below it. So right about here. And then 4, 0. And then I'm going to make a graph. Now if you notice, compared to the parent function, this graph kind of got squished like a soda can. If you can picture, this guy here got squished, got stepped on. Okay? So this is called a not vertical stretch, but a vertical shrink. And you can say by a factor of a half. Okay, the last one we're going to talk about is multiplying by negative 1. And that's going to change all the y values, not the x values, because remember f of x means y. It's going to change all the y values to negate from the original. So the original had 1, so that would be negative 1. 1 again, that's another negative 1. Here it was 3, so we're going to make it a negative 3. The other one was, let me just look at my original table, was negative 3, so negative 3 times negative 1 will get you positive 3, and then that'll stay 4, 0. So I'm going to reflect everything. So negative 1, negative 4, negative 1, that's here. Negative 1, negative 1, that's there. 1, negative 3, 1, 2, 3. And then 2, 3, 1, 2, 3. And then 4, 0, 1, 2, 3, 1, 2, 3, 4, 0. And then we'll connect it. And if you could notice, this did reflect over the x-axis because we negated y. So this is going to be a reflection over the x-axis. Okay. Okay, so now we're going to talk about the general form of a function. We haven't really gotten into the parent functions yet. We're going to get into that in a second. But this equation right here is how every single thing that can happen to your parent function is going to be affected. So the a in front, that's being multiplied. So remember, that was the vertical stretch or vertical shrink. Okay, so this is the multiplication here. So if a is a value greater than 1, it's a vertical stretch. If a is less than 0, remember that was the negative in front of that f of x in the previous slide, that was our reflection. Let me just make this a little bit bigger so I'm not writing as small. Because my handwriting is getting pretty rough right now. So this is a vertical stretch. When a is less than 0, that was the example where it was negative f of x. That's going to be a reflection over the x-axis. So when it was greater than 1, that was the one when we times it by 2. That's your stretch. When it makes a shrink, though, the number has to be between 0 and 1. So we're going to use the symbols less than or equal to. This means in between. So 0 is less than a, which is less than 1. That means in between 0 and 1. And when that happens, when the a value is like that, just like the half that we had, because between 0 and 1 is a half perfectly, that's called a vertical shrink. These are just straight notes. It's nothing. It's something that you're basically going to memorize or get used to. So the next thing I'm going to talk about is the h. Now, if you notice, the h here is negative, and that kind of helps us understand why it was opposite of what we thought. Because a negative h will do the opposite. It changes the sign. It changes the direction. So our horizontal shift, if you have an h value that's positive, it moves it to the left. So positive moves it to the left. Because remember, if it's x minus h, and you put another negative in there, that's why it becomes that positive value. The negative makes more sense to moving it to the left, but remember the equation has the negative in it already, so it changes the sign. If it's negative, it moves it to the right. And this makes sense because when you have a minus in there, when you move something to the right, usually it's a positive value when you go to the right on the x-axis, but if this is a positive, it ultimately becomes a negative there. So basically, inside the parentheses means left or right, and I always think it's opposite of what I think, okay? The k value, the vertical shift, this one's not opposite of what you think. The k value is always outside the parentheses, and this means up or down. When you see a positive value, it's up, and when you see a negative value, it's down, straightforward. So I'm going to go over a few of these. I'm not going to do every single example in here because you guys should be able to look at the key as well. I don't do all the examples in class either, so it's not like you're missing out. Okay, so let's go over a few things with the first one. I see something inside the parentheses, and I see something outside the parentheses. This is going to be outside, so it's up or down. I think of like a firehouse. So this is my firehouse right here, and if there's something like a building on fire, you want the ladder. The ladder's on the outside. The ladder can only go up and down on the fire. Outside the house. So because it's positive, it goes up 2. When you're inside the house, you guys know I'm silly. So like when I'm inside the house, I don't know what direction I'm going because of the smoke. So minus is opposite of what I think because I'm confused. So that -1 means I'm going right 1 unit. Okay. So I'll do another one here. This is left or right, up or down. Because it's inside the parentheses, it's opposite of what I think. When I see positive, it's left 7. The 8 is outside the parentheses, so that's up 8. The 2 here is multiplying the f of x, so it's a vertical stretch by a factor of 2. And we have an x minus 1 on the inside of parentheses, so that's moving right 1 unit. Okay. In this one here, number 4, it's a little bit different because you see there's a negative here on the outside. There's also a 3, and there's also a 2. There are 3 things happening here. Don't think of the -3 as one piece. It's actually 2 pieces, 2 separate pieces. The negative does something, the 3 does something, and the 2 does something. So that negative is the reflection over the x. This is your reflection, the x-axis. The 3 is your dilation, which is a vertical stretch. And then it's going up 2 units. The next one, there's a 1/2 in front. This is less than 1 and in between 0. In between 0 and 1 is going to shrink this vertically by a factor of 1/2. And this 9 is on the outside of the parentheses, so it's going down 9 units. Okay, so if you want to look at the key for the rest of these, go for it, but that's pretty much the gist of that. Okay, so we're going to practice with the absolute value and quadratic functions. So we're going to graph these guys in your calculator. So you're going to type in y equals the absolute value of x plus 4. So remember, the absolute value bars are going to be under math num abs. Now, here's the deal. The parent function of this starts at the origin, like this. I'm not going to make anything pretty here. And what's happening to this function is that it's moving left 4 units, okay, because it's a positive 4 on the inside. So you're going to see that it's moving left 4. So this vertex is going 1, 2, 3, 4. I'm just sketching for now, but on a test or a quiz, I would expect you guys to actually plot the points on your calculator. This guy here is outside the parentheses. That means it's going to take this blue parent function here. The parent functions always usually have to do with the origin. They usually start there. It's going to take this blue guy and move him down 5 units. So 1, 2, 3, 4, 5. That should be what your graphing calculator shows. Okay. The next one here is doing two things. It's taking the parent function and moving it right 3, because that's a negative 3 on the inside of the parentheses in a way. I know that these are the bars of the absolute values, but they behave the same way as the parentheses. So what's going to happen with this guy here is it's going to move right 3, because that negative 3 on the inside of the absolute value bars is like the parentheses, and it's also going to move it up 2, because this is outside the bars, or the parentheses if you want to think of it that way. So I'm going to move right 3, 1, 2, 3, up 2, and again you can plot this on your calculator and get the perfect points, but again I'm just creating sketches here because all we're really talking about today is translating them. Okay, so now we're going to talk about some quadratic shifting. In this section it's talking about the quadratic and the absolute value. So you can tell these are quadratics because they have their squareds right here. So remember, the parent function for x squared has a vertex at the origin, and then it looks like our U shape. Okay. In this case, we would be moving, for this example, down. We'd be moving down 6. And that's because it's outside of the x squared and going with a subtraction of 6 units. So it would be 1, 2, 3, 4, 5, 6. If you guys want the exact points, again, you can type it into your calculator, but just for the purpose of note-taking, I'm just making sketches freehand. This guy here, this is inside the parentheses. It's an x minus 3 on the inside. Remember, that means opposite of what you think. So it's actually moving right 3 units of the parent function. So remember, the parent function of a parabola starts at the origin, so I move it right 3, 1, 2, 3. If you want to see the actual picture, please go ahead and type this into your y equals and press graph. So this would be right 3 units. The next guy here has inside and outside. Remember, the inside is left or right, the outside's up or down. Because it's x plus 2, it's going to go left 2, and it's going to go plus 1, so that means up 1 unit. So it's going to take that vertex and go left 2 and up 1 unit. And there's your sketch right here. Okay, so the next section asks you to state the transformations from the parent. So I'm going to first state the parent function and then give you the transformation. So this is the absolute value parent function. This is the parent, just with the bars. And then because there's a plus 5 on the outside, it would be up 5 units. The parent function for number 6 would be y equals x squared, because there's a squared there. But there are two things happening here. There's the minus and then the minus 4. The minus in front of the x squared creates a reflection over the x-axis, and the minus 4 on the outside creates a down 4 translation, a vertical translation down 4 units. You can check the key for the rest of these, but I'm just going to go through them verbally. This guy is on the inside. Its parent function is the absolute value, and because it's plus 2, it's going left 2 units. This guy here is on the inside of my parentheses again. This is parent function is x squared. It's the quadratic, and again, because it's plus 5 on the inside of the parentheses, it's going left 5 units. The next guy here has a negative and a 4 in front of it. There are two things happening here. The negative is causing a reflection over the x-axis, whereas the 4 is multiplying the absolute value, so it's causing a dilation, which is a vertical stretch by a factor of 4. This guy here has a 3 in front multiplying. There's your vertical stretch by a factor of 3. X minus 9 is on the inside of my parentheses, so that's a shift right 9 units. And it's going up 1 unit because this is outside the parentheses. The parent function of this guy is y equals x squared. This person here, he has a 2 multiplying the absolute value bars. There's your vertical stretch of 2 units, a factor of 2. This is going left 6 units and down 7 units. Remember, this is inside the absolute value bars, so it's left or right, and outside the absolute value bars is up or down. Now 5 and 9 are a little tricky because if you can see, it has the 7/5, but it's not written normally. So I'm just going to write it with it pulled out to the front so you guys can see that there is a fraction in front. And this guy I'll write -1/2 because that's what is in front of that absolute value. So for this guy here, there's the negative, the half, the -8, and the +1 occurring at the same time. The negative in front of the absolute value bars is going to reflect over the x-axis. The 1/2 is going to cause that vertical shrink. The x minus 8 is inside the absolute value bars, so this will cause a right shift 8 units. And this +1 will cause an up 1 shift vertically. Now this example is a little tricky because 7/5 is actually bigger than 1. So it's not going to create a vertical shrink. It'll create a vertical stretch. It'll stretch the graph by 7/5. It'll also go right 4 units and then down 2. The next section is asking you to write the parent function given the shift happening. So y equals the absolute value of x. So what we're going to do is manipulate this thing. So what I want to do is I want to make this go up 7 and left 3 units. So in order to do that, what I need to do is remember that up 7 would mean up 7 units outside the parentheses. In this case, it's absolute value, so I'll be adding 7 out here. The next part says left 3. Left 3 is going to be inside the absolute value bars, and that's going to be +3 units. The next one's also an absolute value one, so I will be writing y equals the absolute value of x. I always like to write this first and leave myself a little space. I'm going down 4, so I'm going to put a subtraction of 4 on the outside, and I'm going right 1, which is a subtraction of 1 on the inside. Okay, so the next one says right 6 and a vertical stretch of 2. So right 6 means that I'm going to do -6 on the inside, and a vertical stretch means I need to dilate, which means I need to multiply. So I'm going to multiply by 2 on the outside. Next one is a quadratic because of the x squared. So I'm going to make my parentheses and a squared. It says left 5/3, so that means I'm going to do x, left is positive 5/3 on the inside, and then up 7/12, so +7/12, and a vertical stretch of 4/3, so I'll multiply by 4/3 on the outside. The last one is an absolute value. I'm going right 9 units, which is x minus 9 on the inside, and down 2, so subtract that 2. The next page has to do with more examples just like that. You guys can look at the key if you want more of those. But the next one we're talking about is practice with shifts of cubes and square root functions. The parent function of this guy is y equals the square root of x. I'll show you what's extra here. This is extra and this is extra. The square root of x is the original. And remember, the square root of x looks like this. But in this case, it has a -2 on the inside and a +3 on the outside. So remember, if there's something on the inside, it means left or right. And in this case, it's inside the radical, so this would be right 2 units. And then the +3 would be up 3. So I'm going to take this guy here, this point, I'm going to go right 2 and up 3. So I'm going to go right 2, 1, 2, up 3, 1, 2, 3. And there's my sketch. I know it's nothing pretty, and you guys can get better points by actually graphing it with your calculator, and that's what I prefer you to do. But I'm just trying to run through these notes so that you guys can have a nice video on how to do all these things. This is a cubic function, so the parent function is y equals x cubed. And there's 2 things happening here. There's a multiplying by 2, so that's a vertical stretch of 2 by a factor of 2, and +1's moving this left 1 unit. So remember, the original parent function looks something like this, and we're going to move it left 1 here, and we're going to stretch it. And again, you can get more points if you use your calculator. So we're going to describe the things that are happening here in these examples. The parent function here is y equals x squared. That's your parent. I'm sorry, y equals the square root of x is the parent here. And what's happening is down 6 units. The next one here, the parent function is y equals x cubed because there's a cubed, and we see a reflection over the x-axis, and we also see a vertical shrink because 4/3 is less than 1. The parent function here is y equals x cubed because we see a cubed, and the inside of these parentheses is plus 4, so that means it's moving left 4. Parent function here is also y equals x cubed. I see two things happening here because there's a minus x on the outside of that x cubed and a minus 6 directly after it. That minus x cubed is actually creating that reflection over the x-axis, and the negative 6 is moving that parent function down 6 units. The parent function here is going to be y equals the square root of x. And the thing that's happening is a vertical stretch by a factor of 2. This guy here is also a parent function of y equals the square root of x. And this one is going left 7 because we have plus 7 on the inside. And we're going up 5 because of the plus 5 on the outside. Okay, the next part goes over the same thing, so I'm going to skip that. We're going to write the equations now. And we're talking about cubic and square roots this case. So I'm going to make sure that I have y equals the square root of x because that's my parent, and now I'm going to manipulate it. They're asking me to go down 4 and right 2. The right 2 will go on the inside of the square root. Make sure that square root goes over that whole entire thing. And down 4 is being minus 4 on the outside. So that's my new equation. The next one is x cubed. So just like the x squared, I want to make sure I write my parentheses first and leave a little space if I move anything from right to left. So they tell me it reflects over the x-axis and it moves right 3. Reflecting over the x-axis, I'm going to move that negative on the outside, and I'm moving right 3, so I'm subtracting 3 on the inside there. Okay, so for the next one, we have a vertical shrink, and we have a parent function of, first off, we have a parent function of y equals the square root of x. So I'm going to write y equals the square root. We have a vertical shrink, so we multiply the 2/5 on the outside, and we're going left 7, so x plus 7 on the inside. Okay, so the next guy here is our first one that we reflect over the y-axis. When you reflect over y, you negate x. So we're going to put a negative x on the inside. Moving up 6, that goes on the outside of the square root. The last one is a parent function of x cubed, so I'm going to write my parentheses, and I'm going to vertical shrink by 2/3, so I'll put that in the front. And I'm going left 9, so I'll add that 9 on the inside. So remember, left or right goes inside the parentheses, up or down is outside, and then the vertical stretch, shrink, and reflections are multiplied in front of the graph. Now I believe some of this might have messed up for you guys, but you can just watch this video. Also, the proper printout is on my not my eBoard. Well, it is on eBoard, but it's on Google Classroom now. So the first thing I always ask is what's the parent function? And that's why we need to know what they look like. This guy looks like a v, so it's the absolute value of x. Now I want to find what happened to this absolute value of x. Remember that they always start at the origin. In this case, my value moved up 3, so it's going to be plus 3 on the outside of that absolute value bars. This guy here is x squared. Usually x squared starts at the origin as a u, parabola. This one moved left. It moved left 1, 2, 3, 4, 5. So I'm going to write my parentheses and do x plus 5 squared. The next one is a square root. And the reason why we know it's a square root is because it looks like that parent function. The parent function of a square root, if you remember, starts off here. So this guy here moved down. So I'm going to write my square root of x, and I'm going down 1, 2, 3. So I'm going to subtract 3 on the outside of my radical. There's some more examples here. This guy here is a little bit different because we have a flipped over parabola. So we can see that it's y equals x squared as our parent function. So I'm going to go ahead and write my setup here, which is the parentheses with the squared. I know it reflected over the x, so I'm going to negate it. Because remember, originally it looks like this, like a happy face U. It's a sad face U right now. And it went over to the left, to the right, I'm sorry, and up. It moved over 1, 2, 3, 4 right, so that'll be -4 on the inside, and up 1, 2, 3, 4 units. The next one is an x cubed graph because it looks like the parent function x cubed. So I'm going to set up my y equals x cubed. Now again, if you want to see how these are working out, you can always type in y equals x cubed into your graph and kind of see if this looks like it. And it does. If you remember, x cubed looks like this, except this guy was moved to the left and down. So since it was moved to the left, we can count how many boxes it was moved over. It was moved over 1, 2, 3, 4, 5. So it'll be +5. And it moved down 2 units, so -2, because it moved down 2 units. We already did an absolute value one, so I'm going to skip that guy. We already did a square root, so I'm going to skip that one. And we already did a cubic, so we'll skip that one. You guys can look at the notes if you want the answers to those. Okay. The domain and range is the x and y values. If you can see here, this is an ellipse. So the domain only goes from this way to this way. Those are the x values it can expand over. So I'm going to use brackets because it's going to 2 points from left to right. It only stretches out from left to right. Remember, the domain is your left and right value. So I'm going to write domain on top of this. It's going all the way from -1 to 1, 2, 3, 4, 5, 6 to 6. The range is the up and down values. It goes all the way up here to all the way down here. Those are your range values. And the lowest value is 1, 2, 3, 4, 5, 6. So -6, 2, and it goes all the way up to 1, 2, 3, 4, 5, 6. The domain for this guy here, remember domain is x, left and right. I can travel left to right, but I get stopped right here on the right. This is the last or the furthest right point I can go. So I can go all the way infinite over here because the arrows point all the way to the left. But in regards to the right side, I can only go here. So what I'm going to write is for my domain, for this graph, I can go all the way left to -infinity. That's why I'm using my parentheses, because you can't contain infinity. Remember, the parentheses is when you can't contain something. And then my last point here is this guy here, and that's going to have a bracket because it's an actual point. Whenever you have an actual point and you're writing the domain, it's a bracket. It's going to be 1, 2, 3, so that'll be 3. That's your furthest right x value. The range in this case, though, you can expand this graph all the way up because this grows all the way up and all the way down. So because it expands all the way up and all the way down, it's all real numbers. So the range here is all reals. The next one, domain, is your x values. Remember, it's from left to right for x values. So the furthest left value is this guy, and the furthest right value, well, it keeps going on and on forever and ever. So all I have to worry about is really this side here, and that left value is 1, 2, 3, 4, 5. So it's -5, and if you notice, it's an open circle, so there's no point there. So I'm going to use a parenthesis, whereas it's different from this one where there was a point, and if you notice, I used a bracket. And because it goes all the way to the right, I'm going to do positive infinity here. Okay, your range would be the y values for this, and the y values for this would go up and down, because that's the range values, and the furthest one down here would be 1, 2, 3, 4, 5, so that would be -5 again, and it goes all the way up, so that's also infinity. So we're going to do -5, comma, infinity again. The last page of this lesson just goes over more stating the transformations, so you guys can look at the key and get the answers for this. And then if you have any questions, please come to Extra Help.